Okay, fellas, today we're doing 7.4 torque. I didn't say twerk, I said torque. Okay, torque. Here we go. Let's get started. Okay, so what is torque and what is the formula that you learned for torque last period? Okay, so last time I saw you guys we spoke about torque, and remember we said torque is basically angular force. Yeah. And if you remember, we went through the formula. The formula for force on the AP exam is the sum of the formations, the sum of the forces over mass, right? And it's equal to acceleration. But if you remember how we write that back in the school days, it's F equals ma, right? So, how we wrote that last time I saw you guys was angular acceleration instead of acceleration is equal to the sum of the torques divided by the moment of inertia. Yeah? That's what angular mass is, remember? Okay, and then so that is the way that they write it on the AP exam formula chart. Yeah? But what I think you should know and be able to remember fairly quickly is if they talk about torque, you just know that torque, just like how if they talk about force, you should just be like, oh, force is equal to ma. Yeah? Torque is equal to, not ma, but angular mass, which is moment of inertia, and angular acceleration, which is alpha, right? So you should just automatically know that with your torque, right? And these two are the same formulas. You know, this one's written in the more formal way for, calculus-based physics, because if there's multiple torques, then you should be including them. This is more of the, old school way of writing it. Okay, let's go forward here. Okay, how do we easily convert between angular and linear kinematics? Okay, so let's just see if you remember what I'm talking about. So if I have a linear velocity and I have an angular speed, remember, how do I convert between those? And what you do is you multiply by radius, right, with your angular thing. So if you want angular, if you want linear acceleration, you have angular acceleration, you multiply by r, right? Same thing for distance. If you have angular distance, you multiply by r, it gives you your linear distance. So, based off of that, how do you think you could convert between angular and linear force? So if you have linear force and you want angular force, which is torque, what do you think you're going to do? Okay, I know you guys are all going to say multiply by r here, which is wrong. I know. It's sad because on this other PowerPoint, it's nice and easy, and you just want everything to work like this. If I take an angular and I multiply it by r, then I have a linear, right? That's the way that you want it to work. Linear is equal to angular times radius. If it's like that every time, it just makes it easy to remember. But it's not like this on this one. I'm sorry. Here it is on the formula chart. This is the formula chart definition. Now look at it. It's kind of similar. Because look, it's torque, which is angular force, is equal to the linear force times radius, which is the opposite. So if you multiply the linear thing by radius, you get the angular on this one. So it's opposite of these ones. Okay? Now, some of you guys are probably looking at this and saying, why in the world are they putting that for a multiply? Like, that's a big X. Okay, because not really multiply, it's the cross product. Okay? And on the AP exam, this probably won't affect you in any way. If you just remember it as it being torque is equal to force times radius, you're probably going to be fine. Okay? But I'll show you what cross product means in case you get it like in your other physics class. So torque is equal to, okay, cross product, there's a couple different ways to do it, but this is the way I do it. It's the radius times the force, and then cross product is sine of your angle. So that angle is the angle between the two things. And if you're wondering, and you know what, before I say that, remember there's also that other one. I showed you guys one with a dot product before, and it was with a cosine. I'm trying to remember what the dot product one was. I can't remember off the top of my head. Okay, so let's go through this. Okay, so you're probably wondering, why isn't it just force times radius? Well, I'm going to start this with a question. Okay, which picture would be easier to turn this bolt? If you have a car tire iron and you're trying to take a bolt off, would you rather have this, wrench, or would you rather have this wrench? The answer is this wrench. Now, the reason is because the longer you make this lever, the easier it is to turn it, the more force you have when you turn it. Okay? So, let's go back to this real quick. So, if you want torque, what you do is you do radius times force, is what I was telling you, right? So, torque is equal to force times radius. So, in this case, if you're trying to apply a torque to undo this bolt, what you're going to do is you're going to apply some force onto it, yeah? And depending on the amount of radius, it applies a torque. Now, you can either make your force larger. If you need to increase the torque that's going to be done, you can either increase your force or you can increase your radius. If you increase the force or you increase the radius, you increase the torque, right? So, in this case, this one has a smaller radius. So, in order to get the same amount of torque to turn the bolt, you would have to apply a much larger force in order to reach the same torque. Okay? So, you would want this one because the larger the radius, the less force you have to apply to, achieve a certain amount of torque. Now, we said that it had that cross product, right? And you're wondering, like, well, why would I need to do the sign? Okay, so I've never seen them do this on the AP exam, except for, like, conceptual things, not actually calculating. But, like, let's say, if you apply the force directly onto it, then you can just use this. But let's say you apply the torque at an angle. The angle to the 90-degree angle. That amount, all the force that you're applying is not being, put into the turning of this wrench because you're applying it at an angle. Some of the force that you're applying, is applying horizontally into the wrench, right? So if you apply your force at a different angle, then that cross product becomes something that you need to do because you need to find the angle at which it's being applied so that you can use it. But like I said, on the AP exam, I've never seen them use anything at an angle like that or actually calculating it at an angle. Okay, so here's the formulas you got. You got torque is equal to force times radius, and you got torque is equal to moment of inertia times angular acceleration, right? Okay, this is how I kind of want you to memorize them. This is how they are on the formula chart, right? Which these are the same as these. If you want to write this one out more directly, it'd be sine of the angle. But like I said, on the formula on the AP exam, I haven't seen them use that. And on this one, if you want to do it correctly, it's the sum of the torques, right? But if you just have a torque, it's equal to moment of inertia times acceleration. So those are your two formulas. Okay. Let's go through some problems here. I got two problems for you. Solve for the unknown mass. Now, guys, this one should be one that you could do with the center of mass formula. Yeah? And we could do it with both of them. Yeah, let's do center of mass real quick so you guys can remember center of mass. Remember, center of mass is the sum of the masses times the distances divided by the sum of the masses, right? Now, let's go through it. Okay, so let's say that this thing is balanced right here. Okay, so that is your center of mass. So my center of mass is 6. Okay, now it's the sum of the masses times the distances. So here's the first one. 50 times the distance, we're going to count that as 0. Plus, the next one, I'll do this person, which we don't know the mass. That's what I want you to find. Times the distance, which is 6 plus 4. So 10. And then last one, don't forget I'm making the board weigh 20 kilograms. And remember, the mass of a object where everything is uniformly distributed, like a board, is at the center here. So this is the 5 meter mark. So this is where the 20 kilograms of the board is actually being applied. So plus the 5, I should do 20 first. 20, the mass times the distance, so 5. All divided by the total masses added together. So 50 on this, sorry, I put 5 there. I meant to put 50. 50 plus m plus the mass of the board, which is 20. And then you can just work this out. Yeah, I would just use a calculator. That's just going to be 0. So we got 10m plus, this is going to be 100 over 70 plus m. And you just use your calculator to get the answer there. I'm going to pause it so I can just get the answer real quick, okay? Okay, so I just calculated it. I just used the solver function, and it came out to m equals 80 kilograms. And so that's what this person is 80 kilograms, right? Okay, so that's one way of doing it. Now, I want to do it using the torque now instead of using center of mass. Okay, so we should arrive at the same answer of 80. Okay, so here's how you do it with torque. And guys, the reason why you need to know torque is because sometimes it might not be able to be calculated using using the center of mass. And honestly, remember, you don't have too much time on each problem, so you're probably just gonna have time to run through one of them, or take an educated guess on some of them. So, but let's go through it with the force one with torque. Okay, remember, torque is equal to force times radius. And notice the forces that all these people are applying are directly downward, which is perpendicular to this, kind of like when we're turning it, so we don't have to worry about any angles. Yeah? Okay, so let's start with this person. Now, the way that you're going to do the torque is you're going to say the torque on this side, the left-hand side, will be equal to the torque on the right-hand side. Okay? That's what we're going to do. So if you want to write it out here, we're going to say the torque on the left will be equal to the torque on the right. Okay, so let's see. The torque on the left, you have a 50 kilogram person. Yeah? And we should do the force, because it's going to be force times radius. Force would be 50 times 9.8, right? Times the radius here, which is the radius from the center at which it's turning. So the radius would be 6. Okay? Plus, there's another thing on this side, which is the mass of the board on the left-hand side, which is going to be 20 times 9.8 times the distance from where the center of the pivot point is. So from here, that would be 1 meter away, right? Okay, should be equal to the torque on the right-hand side. Now on the right-hand side, all you have is this one person applying a torque this way. Where on this side, you had two things. You had the person and the board. So on this one, we got this person, and we don't know the mass of the person right now. So we're going to say m times 9.8, because that's force, right? M times 9.8, and times the distance from the pivot point, which is 4. Yeah? And then you can just use your calculator to calculate that. And here, I'll pause it while I do it, make sure it comes out to... Okay, guys, and yeah, I just did it. It did come out to m equals 80 kilograms. And some of you might be asking, shouldn't this 9.8 actually be a negative? I just thought about this when I was plugging into the calculator. Shouldn't it really be a negative, because it's force, it's the weight, right? And the force is the person's weight, which is downwards. So yeah, it should be negative, but it should be negative on all of them, negative 9.8. So, I mean, all of these cancel each other out. You could have put any number you wanted. It didn't really matter. The gravities all cancel each other out. But yeah, so that did come out to 80, so you could use it with center of mass or with torque. Now I'm going to do a problem with torque that will be a little different than this one. Now guys, here's just a little hint for the second problem on the homework. I give you 2 of these and I say, how do you calculate for m and x? Just when you do it, set up 2 torque formulas. I don't know if you can do it for center of mass. I haven't tried it with center of mass. But set up 2 torque formulas and then use substitution. Yeah? So like solve for m and then plug in on the other problem. So you're going to have to use some substitution on here because there are 2 unknowns, Remember, depending on the number of unknowns is the number of formulas you need. So if there are 2 unknowns, you need to have 2 formulas in order to solve for the unknown. Yeah? Okay. Last one I got on here. Okay, so you got some disk that's spinning, okay? And it's going to spin to some angular speed of omega f, yeah? So the disk to the right has a mass of 10 kilograms. I'll write everything down, and has a radius of 0.3 meters, yeah? If the disk begins from rest, so our omega naught is 0 radians per second, and reaches an angular speed of 1.5 radians per second. Okay, so we know that the final angular speed is 1.5 radians per second. In 2 full turns. Okay, so that's important. 2 full turns, so it's going to do this in 2 full turns. So we know that our theta in 2 full turns would be 4 radians, right? I mean 4 pi radians. Because 1 full turn is 2 pi, and it does another turn, so 2 pi again, right? So 2 pi plus 2 pi is going to be 4 pi. Yeah, makes sense. Okay. So now we know all the information that was given to us. So it says calculate the angular acceleration of the disk. Okay, so we know that it went from 0 to 1.5. So if we're looking for angular acceleration, okay, so that means you're going to be choosing between those 3 angular kinematics formulas. So just like the kinematics formulas on the front of the board, but we're going to use them with the angular stuff. And just thinking off the top of my head here, I think the one that you would probably use is omega f squared equals omega naught squared plus 2 alpha theta minus theta naught, right? Theta naught being 0, so you can ignore that. Okay, let's plug these in. So 1.5 squared equals 0 squared, because it starts from rest, plus 2 alpha, which is what we're looking for, times 4 pi. And you're just going to solve for alpha, so plug that into the calculator here. So here we go, 1.5 squared equals, hello Des, equals 2 times x times 4 times pi. Solve for x, and our answer is a angular acceleration of 0.09 radians per second squared. Okay, that's our angular acceleration. Okay, now it says calculate the torque applied to the disk. Okay, so torque, remember that's going to be moment of inertia times angular acceleration. So our moment of inertia, we don't know that right now, but we can calculate it. They even told us how to calculate moment of inertia for a solid disk. So it's going to be, so if you want I, it's going to be a half times the mass, which is 10, times the radius squared, which the radius was 0.3 squared. So let's see what I is. That comes out to 0.5 times 10 times 0.3 squared, and that is 0.45. 0.45 is my moment of inertia. And, we should put the units on there in case you guys are confused on the units. Remember, mass is kilograms, and radius is in meters, and it's being squared, so it's kilograms meters squared. That's my units for moment of inertia. So I'm going to do 0.45 times the angular acceleration, 0.09, and this is going to come out to 0.45 times 0.09, comes out to 0.041, and we need to put the units on here. Torque is Newton meters. Newton meters, just force times radius, right? Because we said torque is equal to force times radius. So force is newtons, radius is meters. Newton meters. Okay, and there's the torque. Now, guys, if I give you torque on the homework, I say here's the torque, and maybe you need to know angular acceleration. If you divide torque by I, You know, your angular acceleration could be torque divided by moment of inertia, and that'll give you your angular acceleration. Maybe you need that in order to do, you know, kinematics formulas and stuff. Okay? See y'all later. Have a great day.